Geometry benchmark 0-2 solving equations. Now again, these 0- benchmarks in geometry are simply algebra benchmarks in review. So go ahead and look back at the algebra ones if you want some extra practice on this. First problem, just a straightforward equation I need to solve. First step for me is going to be to distribute the -3 here. If you don't see that this is a -3, maybe change this to plus negative. So I have -4x plus -3x plus 21, positive 21, because I have a -3 here times the -7 equals, and I'm going to distribute here, 2x plus 6. I like to simplify my x's on the same side if they're together, so -7x. I'll swing my x's to the left side, so either just flip and switch, where you make it a -2 on the left, or add -2x to both sides. So -9x. And then subtract 21. And then now we're going to get, oh, that's 21, not 2. Let's fix that quick. 6 minus 20 is -15. And divide by the -9. Negative divided by negative is positive. You just take your calculator and you get the decimals. The directions say round to the nearest tenth, which is a hint that the answers aren't going to come out nice. So just round that. Second problem. This is a problem with fractions, and we're going to try to use fraction busters to solve it. So if you don't remember fraction busters, this should help. Fraction busters is taking the least common multiple of the bottom numbers of all the denominators and using that common multiple to cancel, to reduce the fractions so they're gone. So I'd have to figure out what number does 8, 12, and 6 all go into. This 2 is over a 1. And the first number that they all go into is 24. So I'm going to put the 24 on top of all all 4 parts in this case. And then now I can do 24 times 3 divided by 8, which is pretty big numbers. I just like to reduce them right away. 24 divided by 8 is 3. And it's going to reduce because I picked the 24 because all the numbers go into that. And I'm left with a 3 and a 3, so 3 times 3 is 9. Next part, I have a 24 and a 12. I could do 24x divided by 12, or I can just reduce ahead of time. 24 divided by 12 is 2, and I'm left with a 2 times an x, so 2x. Nothing here reduces. The 24 and the 1 don't reduce, so I just multiply what's left, so 48. And then at the end, I have a 24 and a 6. Reduce those. 24 divided by 6 is 4, and I multiply what's left, 4 times x. Now, because we use fraction busters, now it just looks like a normal equation to solve. I'll take my x's this time and put them on the right side, just to keep the x's positive for fun. I'll take my 48, swing it over there. So subtract 48 from 9. What is that? -39. So it's 39 divided by 2 is -19 and a half. You know, you might want to check these answers as you get them. You know, if I take that 1.7 and plug it in for x up here, if you have time, plug them in all those spots and see if it balances out. It's a rounded answer, so it's going to be close but not exact. And the 19.5 should be exact. So if you put in the 19.5 in for the x's here and here, that should be a balanced equation too. I need a little space. So I'm just going to get rid of this stuff here for the next problems. Now this is a square root problem. Now there's a couple ways to do this. The first way is the cover-up method, or the chunking method, I guess you could call it that, where you cover up what's under the square root. You pretty much just say, well, whatever's under there must be a 25. Whatever that is because the square root of 25 is 5. So then I say, all right, well, what's under there? And it's 5x plus 6. So if that 5x plus 6 is a 25, then I'll take the square root of it and I'll get 5. And then just solve this problem. So subtract 6 divided by 5, about 3.8. Okay. The other way to think of that problem is algebraically by undoing, using inverse operations. If I'm square rooting the left side to undo it, I square it. So I square the opposite side. The square on the left side cancels the square root, and then I'm left with the same exact equation I came up with before. So whatever way you like better. Number 4. Now here we're going to use the cover-up method again. I'm just going to say, all right, whatever's under there must be a 3, or whatever's under there must be a negative 3. Because if I plug in 3, the absolute value of that will give me 3. Or if I plug in a negative 3 there, I take the absolute value of that, I'll get the positive 3 there. So I have two separate equations to solve. So whatever that stuff is, 2x minus 7 is there. And then just solve the two separate equations. So here add 7 to both sides, or flip and switch. And x is 5. Add 7. Now negative 3 plus 7 is positive 4. So x is 5 or 2. And again, you can plug in your number here. Plug in the 5, check it. Plug in the 2, check it. It should work. That's it.